Hello everyone, I am Sheetal Nagar from BTech Electronics and Communication Engineering Department, working as an assistant professor, IIMT Group of College, Greater Noida. Today, my presentation topic is operational amplifier, and we will discuss the basics of operational amplifier in this lecture. First of all, what is operational amplifier? Operational amplifier have high gain, and it's an amplifier which is used for the very high voltage gain and able to amplify input signals with the frequency range which have from 0 Hz to 1 megahertz. An operational amplifier name so because it was originally designed to perform mathematical operations like addition, subtraction, multiplication, differentiation, and integration, etc. in the analogous computers. It has two input terminals. The first one is the inverting, which is represented by the minus sign, and the other one input terminal is non-inverting input, which is represented by plus sign, and one output terminal. Now, a complete amplifier electronic circuit may contain transistor, diode, capacitor, and other components and constructed on a single silicon chip. Area-wise, the operational amplifier IC has the thickness of 5 mm square and the thickness is less than up to 0.5 mm. It is protected by lace plastic. Now, this is the symbol of operational amplifier. Basically, operational amplifier is represented by a triangular as shown in the figure 1. As we see in the operational amplifier symbolic representation, we have two input terminals. First one is our inverting input, and next one is our non-inverting input. And we have two positive DC supply and negative DC supply pins and one output terminal. In figure 2, this is the representation of the operational amplifier IC integrated circuit, that is 741. This is the pin diagram of pin or IC representation for the operational amplifier. The IC of the operational amplifier contains 8 pin as shown in the figure 2, that operational amplifier input terminals, that is inverting input and non-inverting input, are at pin number 2 and 3 respectively. And at the pin number 6, we have our output terminal, pin number 7 and pin number 4 used for the positive and negative DC supply, and pin number 1 and pin number 5 of this IC used for the offset null, and pin number 8 is used for the non-connected, means we do not connect with anything. Now, how can we give the input to the operational amplifier? Means when we give the input signal, it may be sinusoidal signal, it may be the square wave. When we give input at the inverting input terminal of operational amplifier, then we will get at the output a 180-degree phase shift, inverted output, and which is amplified also, as shown in the figure. Now, next one, non-inverting input. As we know that we have two input terminals of operational amplifier. The second one terminal, named it as non-inverting input. When we apply input signal, it may be in any form, and when we apply at this non-inverting input, then the output of this input signal is only amplified. Means which signal is applied at the positive input terminal will appear amplified and in phase at the output terminals. Means in this case, we will have the same phase at the output as in the input also. But signal is amplified as per the requirement. Now, the open loop voltage gain of the operational amplifier is the ratio of output voltage and voltage difference on inverting input and non-inverting input. So, hence we represent voltage gain of operational amplifier by capital A suffix B is equivalent to V naught oblique VID, where V naught is the output voltage of the operational amplifier and VID is the voltage difference on inverting input and non-inverting input. Now, yes, as we already seen that we have two input terminals. One is the on inverting input and another one is the non-inverting input. But when we apply the input signals at the input terminals, we have two input signal modes of operational amplifier. The first one mode is the differential mode and second one is the common mode. Now, under the differential mode, we can use input signal at any terminal and we can ground the other. We can use both terminals, inverting and non-inverting, but we use input signal at only one terminal. Now, let's discuss the cases of input signal modes. In single-ended input mode, one input is grounded and signal voltage is applied only to other input. If the input is applied to the non-inverting terminal, the output signal will be in the same phase with the input signal. Means in this case, when we apply input, sinusoidal input signal at the non-inverting terminal, input terminal, then we will get an amplified output, but this output will be same in phase with the input signal. Now, in the single input mode connection, if the input is given to the non-inverting terminal, in the last case, we apply the input signal at the non-inverting terminal, and in this case, we will apply the input at to inverting terminal, that is okay, and another non-inverting terminal, that is plus represented by plus sign, is grounded, and at the output we will get 180-degree phase shift, and shown like as shown in the figure. Now, in this case, in the differential mode, in the differential input mode, in which we use a double-ended differential input, we use input signal V1 and V2 at both the input terminal, and we amplify the difference of these input signals. But in this case, the both input signals are different. These input signals may be different in the 180-degree phase shift also. Now, at the input, we get VD. VD is the difference between the input signals, and at the output signal, in this case, we will get the amplified difference of these input signals. Yeah, means in the double-ended differential input mode, the difference input is amplified and in phase with the input signal. Now, block diagram of operational amplify. Basically, operational amplifier is a very high quality amplifier. It contains three stages which are connected in cascaded manner, though designs may vary between the products and manufacturers. All operational amplifiers have basically the same internal structure which consists of three stages. Now we will discuss the main stages of the operational amplifier, and this is the block diagram of operational amplifier in which uh, the two inverting inputs are connected to inverting input and non-inverting input, means both inverting and non-inverting input are connected to the differential amplifier. The output of the differential amplifier is connected with the voltage amplifier, and the output of this voltage amplifier is also connected with the output amplifier. And the output of this output of amplifier will be taken as the final output of operational amplifier. Means we are using, we see in the detail of the block diagram of operational amplifier, we have three amplifier in our operational amplifier. The first one is the differential amplifier, second one is the voltage amplifier, and third one is the output amplifier. Now this amplification process of the operational amplifier, we divided into three stages like this. Okay, the first stage of an operational amplifier is a differential amplifier which is double-ended, and it provides low noise amplification, high input impedance, usually a differential output. Now, the second stage is an intermediate gain stage. Okay, and this stage is also provide a very high gain. The voltage amplifier provides high voltage gain, usually single-ended output. The third stage is an output amplifier stage, which provides low output impedance, current limiting, and short circuit protection circuitry. If we look at the first stage, we required a very high input impedance, and at the output side we require a very low output impedance. Okay, means if we talk regarding the characteristics of an ideal operational amplifier, the main characteristics of operational amplifier is ideal operational amplifiers are the high voltage gain, sorry, infinite voltage gain. Ideally, we said it must be infinite. Otherwise, we can say it must be very high. Okay, but we are talking regarding ideal operational amplifier, so we have to say that its voltage gain must be infinite of operational amplifier. Infinite input impedance, zero output impedance, and both input and output impedance will be getting through this internal structure of the operational amplifier. The other one characteristics of the operational amplifiers are the bandwidth must be infinite of the operational amplifier. Common mode rejection ratio of operational amplifier must be infinite, and zero input offset voltage and zero input offset current. These are the main characteristics of operational amplifier in the ideal case. Okay, let's finish our the introduction part of the operational amplifier with the characteristics of operational amplifier. Thank you very much. 10 seconds.